we're going to use Excel to calculate compound interest. So these are the lessons in 4.2.1 and 4.2.3 that we're going to be using Excel for. And there are other ways to do these problems, but by far and away the easiest way is to use Excel, and you will be able to because you can have Excel open while you take your test. Excel works for any kind of problem, but it probably works best for the compounded interest problems. Let's look at 4.2.1 and go through some of these. Don deposited $581 in a savings account and leaves it there for 5 years to accumulate interest at 6.2% compounded annually. Calculate the maturity value he will have in 5 years. So the first thing that we need to do to calculate the maturity value is to find the interest that he will have in 5 years. To calculate maturity value, we can just use the future value function. Future value. FV stands for future value. And if you notice, Excel even gives you a hint as to what it means. So when we type FV for future value and open parentheses, we can see the function that we're going to have equals future value, and then let's press the function key to fill in the values that it's going to have. Rate is in this case, annual interest rate, since it's compounded annually, 6.2%. And then it's the number of periods, and per is 5 years in this case. We aren't adding any money to it as we go along, so the payment is going to be 0, but we're going to start with giving them $581. So I'm going to type negative 581. I could type positive 581, and then it will give me the opposite answer. And if you notice right now, it's already telling me my answer is going to be $784.87, which is what the answer is for this problem. But when I click the OK key, it puts in the $784.87. I'm going to go back and show you that if I would have made this positive, the answer would have been negative 784, and it illustrates that using parentheses and a red number. So the reason that it's negative is that if they give you the $581 at the beginning, then you have to give back $784 at the end. If you pay out $581 at the beginning, then you get back $784 at the end. Next one, Ginger. This time the account, it says, is compounded semi-annually. Let's see how that changes our problem. Calculate the maturity value or the future value. And so once I start that, I can get the different values figured in. It's 0.052, but since it's compounded semi-annually, I have to divide my 0.052 by 2 and get 0.026. In other words, each half year it only gets 2.6%. Since there are 3 years, but there's 2 semi-annuals per year, notice that gives us 6 compounding periods. Once again, we don't add any money during the time, and you deposit, in other words, you're going to pay out $595, and if you notice, you will have $694.07 when you're done. Next one. Compounded quarterly is the only difference here. So let's compound this quarterly equals, calculate the future value, and fill in our amounts. The rate is 0.078, but since it's quarterly, we're going to divide by 4. Number of periods is 2 years times 4 quarters in each year. We're adding money during the time, and we pay out, give the bank $740. at the beginning, and made a mistake there. Oh, 0.078. Not 78% interest, but 0.078% interest. And we get $863.63. Next one. Let's see what's different here. Calculate the future value she will have in 5 years equals future value. The rate is 0.066, and it says compounded semi-annually, so I'm going to divide it by 2. Number of periods is 5 years, but there's 2 semi-annuals each year. Present value is $1,120, and she will have $1,549.61 at the end.